Helping Airlines Math and History, and we're going to be talking about the surface area. And happy holidays! So, during the holidays, you probably celebrated like Kwanzaa, Christmas, maybe Hanukkah, and those include presents that you get during the holiday, and how do they make the presents? That is why we're going to look at surface area. So, when you're making a gift or a present, you're usually using wrapping paper that surrounds some sort of box. Most presents are in the shape of a cube or a rectangular prism. So, what the surface area does is it measures the outside part of the box. If you measure the inside part of the box, that is something totally different. The inside is the volume, or what's inside the box. But since we're doing the surface area, what we have to do is calculate the outside of the box, like here, and etc. Here's an example of surface area.
I do have one more available. It's the only certified indestructible shell I've ever seen, but I'm sure you'll find a way.
Before we do the handoff, let me take a few precautionary measures. And now a thick layer of bubble wrap. You sure you don't have any more in the back?
So when you're working with surface area, there's no specific primary formula, meaning there's not just one formula out there. If you're using a cube or rectangular prism, you will have to measure all the sides of each face. But if you're measuring like a cylinder, or if you're measuring like a sphere or a cone, then the formulas for the surface area is going to be totally different. Now let's calculate the surface area for this red object shown on the screen. So the dimensions are 70 by 20 by 15. But these are in millimeters. So the first thing that you might think is, oh, let's calculate the volume. But remember in the first part of the video that the volume was the inside of the object. What we want is the outside. So, to understand this a bit more better, we're going to be looking at a net to show what each face of the area is, or what each face area is. So since this is a rectangular prism, this is what it would look like if you take apart every shape and fold them onto the bottom, lay them flat. So when you have a 3D shape, it's made up of basically smaller 2D shapes that make up a giant 3D shape. And it has 1, 2, 3, 4, 5, 6 other shapes that make up the rectangular prism. Let's look at this one first. So since we are trying to find out what that area for that rectangle is, remember, any square or rectangle is the area is going to be the base times the height. So, we have to look at the top because that 2D shape, put it back together, will make a 3D shape. And boom, this is what we're going to be calculating. So the dimensions for A equals base times height is 20 multiplied by 70. And we'll be able to get the area for this rectangle on the top. We also get to find the area on the bottom, because look, it has the exact same dimensions. So, when we calculate 20 multiplied by 70, we get an answer of 1,400. And we can also say that the bottom is also 1,400, because in order for it to be a rectangular prism, the top and the bottom must be the same area. But what happens if we say, if the top and the bottom view have the same amount of area inside the given space, Does it also mean that the side views are also going to be 1,400? Not always, because you gotta be very careful, because when you look at the dimensions, you have to look at, is this side right here, the same thing as saying this side right here? So what we're gonna have to do is find the dimensions for this side right here. When we do that, we get right here 70, and we also get 15 as the height. So if that is 70 multiplied up by 15, and it's not 20 multiplied by 70, or vice versa, it means that they are not the same. So these two columns are going to be totally different. And not all rectangular prisms is going to have every side that's going to be equal. When we do 70 multiplied by 15, we get an answer of 1,050 millimeters squared. So we're going to put 1,050 right here, and we also put 1,050 over here, because these two are the same. We were talking about the front and the back view. So this and this. That is 1,050. The last step we need to do is try and find what this is and find out what that is. Then when we add up all the numbers, we'll be able to get our surface area measured in millimeters. So, to find the last two squares for their area, what we're going to have to be doing is looking here and looking over here. So what we're going to do is move to the right. So when we look at the right, let's look at the dimensions. So from here all the way to there, it is 20 millimeters. And from the bottom to the top, it is 15 millimeters. What is the area of just this square right here? Then, this rectangle right here. Then we'll be able to find the other rectangle, because when we look at the other side, we realize that it's pretty much the same exact thing. So, 20, multiply that by 15, we're gonna get an answer of 300 millimeters squared. So we put 300 right there and 300 right there. So we have all the information that we have. All of our 2D shapes is now fitted and inserted with numbers. Let's add them all up and get our answer as surface area in millimeters squared. So 1,050 plus 1,400 plus 1,050 plus 1,400 plus 300 plus 300. Due to the cumulative laws, it doesn't matter what order you add them all in, because it will drive you to the exact same answer. So when you calculate this, we get an answer of 5,500 millimeters squared, because we're talking about 2D shapes that make the 3D shape. If it was millimeters cubed, that is when you're using volume. But here is our answer. If you measured in millimeters and you wanted to wrap this box or this figure shown with wrapping paper for Christmas, it would take up 5,500 millimeters of wrapping paper to cover this whole thing. That is the surface area. I hope this video has helped you. Thank you for watching Taoping Airlines Math Industry. Like and subscribe. And what did you get for Christmas or any other holiday? Type in the comments below. What I got for Christmas is I got a robot from Vex Robotics IQ. Happy holidays, folks!